In this exercise, we show that a constant function is integrable, and if f of x equals c on the closed interval a to b, the value of the integral is c times b minus a. When using the formal definition of integral, there's a few things we need to define. First is a partition of the interval. And the standard way to do that is to set one endpoint equal to x naught, and then have x1 through xn with xn equal to the other endpoint. The other quantities are m sub I of f, which is the infimum of the function on one of the intervals of the partition. And then capital M sub I of f is the supremum of the function on one of the intervals. Now, since f of x equals c, we know that the infimum and the supremum are both equal to c. Therefore, when we calculate the upper Darboux sum using this formula, the summation from 1 to n of capital M sub I delta x sub I, we can simply substitute c in for m sub I, and then each delta x sub I is x sub I minus x sub I minus 1. Taking the c outside of the sum, we're left with this expression, and then we're going to write out each of these. So the first one is x sub 1 minus x sub 0 plus x sub 2 minus x sub 1, and so on through x sub n minus x sub n minus 1. Here we do a little bit of rearranging. I'm going to move the parentheses around x sub 1 minus x sub 1, leaving out negative x sub 0 here. Now we see we have a cancellation at each index all the way up through x sub n minus 1. And then x sub n doesn't have a partner. So all of these cancel and we're left with c times x sub n minus x sub 0. And based on our definition of the partition, that equals c times b minus a. Now the lower Darboux sum is going to be exactly the same as the upper Darboux sum because m sub I of f equals capital M sub I of f, which equals c for all I. Therefore, since these two are equal, the integral exists, and the value of the integral is c times b minus a.